Solving trigonometric equations, picking up with example 6, solve sine x tangent x equals sine x on the interval 0 to 2 pi. The first thing you want to do is subtract the sine of x from both sides to get everything onto one side and set it equal to 0. The next thing we want to do is to factor, which means pull out the sine of x. This is like the reverse of the distributive property. What we do next is to set each factor equal to 0 and solve. So either the sine of x is equal to 0 or the tangent of x minus 1 is equal to 0. To figure out the sine of x is equal to 0, think of the unit circle. Where do we have a y coordinate of 0? Because that's what the sine is. The sine is the y coordinate. So after a turn of 0, we're at 0. And then after a half turn, which is pi radians, or 180 degrees, we're also at 0. So that gives me my two solutions, 0 or pi. To solve the tangent of x minus 1 equals 0, first add the 1 to both sides. What angle gives us a tangent of 1? We need to use the special 45, 45, 90 triangle. Tangent is TOA, opposite over adjacent. So the tangent of 45 degrees, or pi over 4, is equal to 1. Now, I'm going to get a second solution, 5 pi over 4, because tangent is positive in quadrants 1 and 3. So if my reference angle is 45 degrees, or pi over 4, if I add the period of the tangent function, which is pi, to pi over 4, then I land here, and that's how I'm getting 5 pi over 4. The other way to think about it is the tangent is the slope of the line. So what I'm saying is, where does my line have a slope of 1? After a 45-degree turn, or a pi over 4 turn, I have a slope of 1. And if I extend that line into quadrant 3, I will still have a slope of 1. So that's why the tangent is the same in quadrants 1 and 3. So just take the pi over 4 and add pi, which is 4 pi over 4, and you get 5 pi over 4. And that's the only other one you can get in this interval.